Integration techniques, lesson 4, the antiderivative of inverse trig functions. Having established the differentiation rules for inverse tan, inverse cos, and inverse sine, the results can be used when generalizing the antiderivatives. The antiderivatives involving inverse trigonometric functions are, when we see the integral of 1 over the square root of a squared take x squared, we can write that as the inverse sine of x on a plus c. Similarly, when we have negative 1 over the square root of a squared take x squared, it's arc cos x on a plus c. The last one is a bit more telling. It's a over a squared plus x squared dx, and that's the inverse tan of x over a plus c. Putting those into practice, example 13. Determine the antiderivative for 1 on square root of 16 take x squared. I'll give you a bit of a tip here. Looks like a situation where we're going to have the inverse sine as our derivative function. Solution. Let's rewrite our integrand as 1 over the square root of 4 squared take x squared, just to show that our a value is 4. Hence, it's the inverse sine of x on 4 plus c. It's a nice short and sweet one. Example 14. Determine the antiderivative for 12 on 9 plus x squared. Let's write our integrand, but first let's have a look. Looks like a situation where we have inverse tan being our answer. So we're going to rewrite our integrand. We're going to set up our integral first, which is 12 over 9 plus x squared dx. Now let's rewrite this. The 9 here, we know is going to change to 3 squared. That way we can have our a squared. We need that a to be at the top as well, numerator. So that's 3 is written here as a factor of 12, which is why it's 3 times 4, making that 12. Hence, I'm going to end up with a situation where I've got a over a squared plus x squared. Let's remove this 4 and rewrite it as 4 lots of the integral of 3 on 3 squared plus x squared. That integrand now turns into the inverse tan of x on 3 because our a value is 3. So the answer is 4 arctan x on 3 plus c. Example 15. Here we have a situation that looks like another inverse tan, but we have 1 over 25 plus 4x squared. First step is rewriting our integrand, which is we want that to be an x squared. So divide everything in our denominator by 4. So 1 over 4 outside of 25 on 4 plus x squared. You can remove this 1/4 now out to the front. Now, two things have happened in this line. 25 on 4 is now 5 on 2 squared. That way I can create this a squared. Now my a value is 5 on 2. I have to have an a in the numerator. So let's make that 5 on 2. But originally it was 1. So hence I'm going to multiply my integral by 2/5. 2/5 times 5 on 2 is the 1. But I've set up a situation where I've got a over a squared plus x squared. Simplifying it again, 2 over 20 is 1/10, a over a squared plus x squared, which is 1/10 arctan 2/5 x plus c. Now, before you think something's gone wrong, a was 5 on 2. And if you have x divided by 5 on 2, you're going to get 2/5 x. This is a bit trickier, this one. And that is our last example, which finishes our lesson 4 on antiderivatives of inverse trig functions.